Hi everyone. Let me first of all introduce myself to all of you. This is Ashnat Kothari here. I'm a teacher, an actuarial science educator, and a minimalist. So let me first tell you this: the audience which should be looking at this video who might find it relevant. Anyone who loves solving puzzles, mathematical puzzles, brain teasers. This is a video which you should be watching till the end, or anyone who likes to solve probability based questions. In particular, given my actuarial science background, anyone who has been associated with actuaries at any let's say in any capacity, this is a definitely must watch video for you. Whether you are a fully qualified actuary with tons of corporate experience, whether you are an actuarial science student with certain number of papers cleared, or you are looking forward towards clearing actuarial science papers, definitely you should be looking at this video. The only prerequisite over here is that you should have an understanding of probabilities. Apart from that, throughout the video you could hear a lot of technical terms, but if you watch the video till the end, you'll understand that it's basically about probabilities which I am talking about. So this question which I am talking about is basically from an actuarial science exam CS2, which had come from IFoA Institute in April 2022. If I correctly recall, the examination was on 19th April, and that was the day when I first took a look at this question as well. Given work commitments, and given it's a new admission session at my education institute, and the students are also appearing exams for same, I wasn't able to devote time at a stretch, and for the past 10 days this was there in my head. I need to sit down and crack this question, and finally just few minutes back before recording this video I was able to solve the question. And let me tell you, the satisfaction which I got from it, I don't recall when was the last time, probably a year or 2 year back. I would have got this level of satisfaction, and that is the reason I am, creating this particular video, solving, trying to solve this particular question. So let me share my screen with you all with the question. This is the particular question which I'm talking about. The number of customers NT in a queue at each integer time t is modeled using a Markov chain model. At the start of each time interval, a number of customers following a Poisson distribution with parameter p join the queue, subject to the constraint that the number of customers in the queue can be no more than n max. Again, just a quick check. We assume that our viewers understand what a Poisson distribution is. Anyone with basic statistics background should be knowing this. At the end of each time interval, a number of customers following a Poisson distribution with parameter q, where q is greater than p, are served and leave the queue, subject to the constraint that the number of customers in the queue cannot be negative, which makes perfect sense. You cannot have negative people in a particular queue. At the most, you could have zero, but you cannot have -1 customer in a queue. So part two is what I'm looking at, where basically we need to verify by separately considering the two transition matrices of customers joining the queue and customers leaving the queue, respectively, that the transition matrix of NT is below. We have been given that Nmax is 2. That is, at the most, there can be two customers waiting in the queue. P is 0.5, Q is 1. So now let me give you a little bit of background, because I would want a lot of you, especially the ones associated with actuarial science, uh, to give you some insights with how I approach the question. A lot of you tend to ask, how was I able to crack this difficult question? What was the sort of thinking and all? And so that is why I would like to go in as much detail as possible. So first of all, I have to concede that I found this to be personally, I found this question to be an extremely beautiful one. After a long time, I've come across such questions. I really enjoy questions of Markov chain and Markov jump, because it really forces you to think. And personally, till the time I cannot get the answer and be able to satisfy myself that I am doing it through correct logic, and let's say not through some backward technique or some back calculation technique, I don't stop at it. So most of the pieces of work which I pick up, whether it's the teaching work or anything else in my corporate domain, I personally have a strong urge to get to the depth of things, simply because I want to be in a position where I can, let's say, teach or transition that work to somebody else. And if I'm asked about any questions from that particular piece, I should be in a position to say, I should be in a position to answer that. Otherwise, I'm not at peace. I should be knowing the things which I'm working on, and till the time I don't get into the depth of things, I won't really be satisfied. That is one of the perks, I would say, of teaching profession, that I do come across these questions sometime or the other, and given my compulsion, can need to solve it. I need to be in a position where I can explain this to any student. I really need to get to the depth of things, becoming a bit more technical, more specific towards the paper. Like, I was able to get almost 6 of these values, and almost 2 of them in each row. And we know that the sum of each row must be equal to 1. So therefore, correspondingly, the third value could have come. So I was keeping a track of my time since 19th April. So from 19 to 27, 28, I could have cumulatively given over, let's say, 20, 25 minutes only. And today I sat around for 20 to 30 minutes. Initially it was, let's say, 10 minutes. Then I was getting stuck. I was not being able to get 1 or 2 values. So my resort to this is just go back, listen to your song, and keep thinking about the question. And trust me, it did strike, key, let's try using this particular approach and see, whether the answer comes or not, because that particular approach was making sense. So from an exam point of view of purpose, I personally was able to solve it, let's say, within 35 to 40 minutes. So obviously for a 8 marks question, you cannot devote that amount of time, because ideally it should be, let's say, maximum 16 minutes. That is 2 minutes for each 1 mark of question. But we have to discount that whenever it's such type of questions, it will always be taking a lot of time. So again, ideally in the examination, part 2 should be the last thing you should be doing in the examination paper. You should be first completing all other things. But just from an academic interest point of view, I would discuss, how to go about this question. So what we're trying to here, view is, let's have a high level picture. We are trying to model the number of customers at a queue. The question states that the maximum number of customers who could wait in the queue is restricted towards 2. Customers are coming according to a Poisson distribution, right? So now you might have the question, in a Poisson distribution, the values can be 0, 1, 2, 3, 4, so on, anything. Here, when we look at the number of, let's say, customers arriving, we need to restrict that to 2, right? So more than 2 won't be possible. So we'll see how to deal with that sort of probability. Then the number of customers who are leaving the queue, that would be dependent on actually, how many customers are there in the queue. Let's say if there is only 1 customer in the queue, then the maximum number of customers who can leave the queue in that particular time duration is 1 only. If there are 2 customers, in that case, maximum is 2. And if there is only, let's say, 0 customer, then obviously nobody can leave the queue. So these are the various things which you need to keep in mind. Again, while solving the question, not all of these come in a very structured way. It comes in bits and pieces, but I've tried to aggregate that up and put it in a really structured way of thought. Now, going forward to how to get this particular set of probabilities. So let's give that a shot. Now, I will first define, let's say, A, which is the number of customers entering the queue. Similarly, I will define B to be the number of customers leaving the queue. So the ones who have studied previously from me would understand the emphasis I always put upon on defining certain things, because it sometimes makes things a lot easier. So I would say, always start with your definition, because it really helps you to reduce time. You might think by writing this thing, it will be taking a lot of time, but unless you're getting the answer at the first go, apart leaving that in all other cases, you'll end up spending a lot more time if you haven't defined these in a very structured way. So now what I'm trying to do over here is get the probabilities. So now what I'm looking at, first of all, again, moving back to the question, just to get, few more things clear. Keep in mind at the start of each time interval, a number of customers following a Poisson distribution with parameter P join the queue. So let's say if I say T to be 4, okay, at time 4, there were N4 in the queue. Just in the next moment, certain customers join the queue. Done. At end of each time interval, a number of customers following a Poisson distribution with parameter Q are served and leave the queue. So how you could think of this is at the beginning of the day, whatever time you set, whether it's 12 a.m. midnight, whether it's 6 a.m. in the morning, 10 a.m., doesn't matter. You define that time. That is the beginning of the day. Certain customers join. At the end of the day, certain customers leave. And then again, we try to see at the beginning of next day, how many customers are there in the queue. That is what we are trying to model over here. So given the question, the state space already has been given. It is going to be 0, 1 or 2. So the number of customers that are going to be waiting at a queue, at each integer time will be either 0, 1 or 2. So now let's logically try to get each and every set of these probabilities. So before getting that, let me separately look at the probabilities of the customers entering the queue and separately the probability for the customers leaving the queue. And then we would be modeling the total number of customers at each time t. So first thing, probability A equal to 0. That is, I want that in a particular day, 0 customers are entering the queue, which would be e to the power minus 0.5. This is straightforward using the formula of a Poisson distribution. Next, what I will see is probability A equal to 1. Now, there is the trick over here. I would be taking 3 different cases. I could take 2 as well. I will take 3 different cases just for complete clarity. So keep this thing in mind. There could be maximum of 2 customers in the queue. So on the last day, at the end, let's say if there was just one customer, okay, there was just one customer. So in the next day, only one more customer could come, right? So probability A equal to 1, given that in the last time, let's say, just at the beginning of the day, I would say just at the beginning of that day, if there was one customer waiting, right? So only one more customer can come. So now think of in this way. Let's say NT is 1. Just before the beginning of day, there was one customer waiting in the queue. So now in the next day, either 0 customer would be joining the queue or at the most 1 can join. So to calculate this probability, what I would be doing is 1 minus probability that 0 customers join the queue, because the probabilities must add up to give us 1 over here. So this probability A equal to 0, you could also condition it upon NT equal to 1. The reason why I'm not doing this is because in all the cases, it's going to be the same probability only. So again, think in this way. Right now, there is one customer in the queue. Okay. The day starts. Either 0 can join or 1 can join. So we cannot find the probability of 1 joining in a traditional way because it's a truncated Poisson distribution. So the way of that is 1 minus the probabilities which you have calculated. Now probability A equal to 1 given NT equal to 0 at the beginning of the day, just before the beginning of the day, there were 0 customers in the queue. So now 0 customers could join that day, 1 could join or 2 could join. So the probability of 1 joining will be defined by using the probability distribution of a Poisson random variable, which will come out to be 0.5 e to the power minus 0.5. And my probability of A equal to 2 will be, I add the probability of A equal to 0 and A equal to 1. Note that 2 customers can join the queue only if NT was 0. Had NT be 1, in that case, maximum 1 customer can join. Had NT been 2, In that case, none of the customers could have joined. Okay. So probability A equal to 2, this would be basically 1 minus this probability plus this probability, which comes out to be 1.5 e to the power minus 0.5. So this is the first thing which you need to keep in mind. Also, if you want to get a bit more specific, I would like to even further break down probability A equal to 0. Probability A equal to 0 given nt equal to 0 is nothing but probability A equal to 0 given nt equal to 1, which is nothing but e to the power minus 0.5. But probability A equal to 0 given nt equal to 2, this is nothing but 1. If just before the beginning of the day there are two customers in the queue, it means that in the next day none of the customers can, let's say, join the queue till the time one does not leave it. So let's keep it very simple that way. So this becomes 1 then, because at this point there are 2 customers, so customers join just at the next point. So at the next point nobody can join, so this probability becomes 1. So this is the first set of probabilities. Again, we are very far off what our final objective is, to get the transition matrix of nt. But so far what we have done is we have found out the probabilities of customers entering the queue in various circumstances. Next thing what I'm going to do is similarly find the probabilities of B, that is the customers leaving the queue. Probability B equal to 0. This will be e to the power minus 1. This is by definition, I would say. Then probability B equal to 1. Given, let's say, n t is equal to 1, wherein here you could, how I would say this nt over here is just at the end of the day, how many customers are there in the queue. Okay. So although technically it's not the correct way, but logically just understand, this is the probability that given that there is one customer waiting in the queue at the end of the day, just before the end of the day, one customers leave the queue. So now if there is only one customer waiting in the queue just before the end of the day, then maximum only one customer could go. So the probability of 0 customers leaving is e to the power minus 1. Therefore, the probability of one customer leaving will become 1 minus e to the power minus 1. Now, probability of B equal to 1 given nt is equal to 2. Say that just before the end of the day, there are 2 customers waiting in the queue. In that case, either 0 could leave the queue or 1 or 2. So 0, so we know it's e to the power minus 1. As if for 1, it will again come out to be e to the power minus 1. Remember that for a Poisson distribution, probability x equal to x is e to the power minus lambda, lambda to the power x by x factorial. Now lambda is equal to 1. So we are left with basically e to the power minus 1 by x factorial. When you put x as 0, you get 0 factorial in denominator, which is 1. Again, when you put x as 1, you get 1 factorial in denominator, which is again 1. So therefore, probability b equal to 0 is nothing but same as probability b equal to 1 given nt equal to 2. And now probability b equal to 2. Note that this is only possible when nt is 2. And this would be what? 1 minus adding up of other probabilities. So 1 minus e to the power minus 1 minus e to the power minus 1. When nt is 2, the probability of 0 customers leaving the queue is e to the power minus 1. The probability of 1 customer leaving the queue is e to the power minus 1. So this comes out to be 1 minus 2 e to the power minus 1. And now using this, the next step will be to find the transition matrix of nt. So let me represent this as ntij. Let me just define to be the number of customers waiting in the queue at time t. This is, let's say, I could say, this is basically, let's say, the probability of j customers waiting in the queue at time t plus 1, given that I customers were waiting in the queue at time t. Okay, so if I draw a timeline, let's say this is time t, and then this is the immediate next time t plus 1. Here, let's say I customers were there in the queue and here J customers are there in the queue. And I'm now looking for the probability of same. So let me start with NT00. NT00 is basically what? Probability that given 0 customers were waiting in the queue, in the next time interval, again 0 customers would be waiting in the queue. Now, this I would say is a very, very tricky part. So let me show you the possibilities. How is this possible? So the possibilities for this are, if there are 0 customers waiting in the queue, okay? So 0 customers would be joining the queue. And if 0 customers are joining the queue, automatically it is surety that 0 customers would be leaving the queue. So this is one possibility. 0 are entering and 0 are leaving. Next possibility is 1 is entering and 1 is leaving. Next possibility is 2 is entering and 2 is leaving. So probability of this will be probability A equal to 0, right, into probability, let's say B equal to 0, given NT is equal to 0. Need to keep this in mind. Why? Because if there are 0 customers waiting in the queue, then it is certain that 0 customers would be leaving the queue. So mathematically, if you write in this way, this could be a lot more easier for you all to understand and appreciate. Plus, let's say one customer enters. Okay. So now what we're looking at is probability B equal to 1 given that NT is equal to 1. Again, note that the definition of NT is not really consistent. Here it's a different NT, here I mean it different. This NT basically represents what? The number of customers in the queue just before the end of the day. So you could use some other way as well. That would be technically more correct. Let's say something like CJ, DJ, BJ, anything like that. Okay. Plus probability A equal to 2 into probability B equal to 2 given that NT is equal to 2. And this will be probability A equal to 0 is e to the power minus 0.5. This is nothing but 1 plus probability A equal to 1 is 0.5 e to the power minus 0.5. Probability B equal to 1 given NT equal to 1 is 1 minus e to the power minus 1. Plus probability A equal to 2 was coming out to be 1 minus 1.5 e to the power minus 0.5. And this probability is nothing but 1 minus 2 e to the power minus 1. On solving, you would get the answer, which is already there. It will match with what is given over here. That is 0.82207 till 5 decimal places. So you could check and you will be getting this as 0.82207. So this is where it took me a lot of time. Given that I was able to put it in a structured way, one could do it even in a non-structured way. So it's everything doing in mentally. But what happens is if you're not getting the correct answer, you again need to start right from the scratch. If you do it in this way, you will understand what things are missing or not. So initially when I was trying, one thing which I was making an error was I was multiplying probability A equal to 0 into probability B equal to 0. So here, if we'll see, probability B equal to 0, I've written e to the power minus 1 only over here. More specifically, I'll also have to separately define that probability B equal to 0 given NT equal to 0 is nothing but 1. So this could be, let's say, written as more specifically NT is equal to 1 or let's say 2. Either of them, either NT is 1 or it is 2, it's gonna be e to the power minus 1 only. Let me just put it NT as 1 only. And similarly for NT equal to 2. So this is what I was trying to multiply e to the power minus 1. I was getting a slightly lower answer and then I was thinking, where am I going wrong? And then it was, also a little bit of back calculation just to see, how to get this answer. So honestly speaking, I was trying to get the answer because this thing wasn't really hitting. And then I saw, how I could come up with 0.82207. And trust me, it takes a lot of time, but what it helps me is that I myself would have told a lot of cases. So whenever some of you would come and ask, why your method is correct or incorrect, I will be directly in a position to, say instantly, why this is correct or this is incorrect. If you would have tried from some other new way, which, I might not have encountered, it would take me time to, say, why this is wrong. Finally, if the answer is coming out to be wrong, then that is naturally your method is incorrect. But as to why, you really need to think about a lot of scenarios, and that's the best part, I would say, of my profession, at least for me. I get to think, and once I'm able to crack that, I'm in a position to explain that question to anyone, whichever method they use. That is the kind of satisfaction, I would say, I'm looking for in my life, and I do get that when teaching students. Although nowadays it comes in a lot more less frequency, given that the classes are online in nature. Hopefully going forward, once offline is back, where I get to communicate more with my students and get to see them physically, it becomes more easier to see whether the students are understanding what I'm teaching or not. So hopefully, this sort of contentment comes more often or with a higher frequency. So yeah, this was NT00. Now let's go to NT01. NT01 means you started with 0 customers waiting in the queue, and in the next time you have 1 customer waiting in the queue. So the possibility for that is 1 customer joining, one of them is joining, and 0 is leaving. This is one possibility. Another possibility is 2 is joining and 1 is leaving. In this way, if basically you started with 0 customers in the queue, you will end up as with 1 customers in the queue. So the probability of 1 joining, given that it was already 0 at the beginning, so probability of 1 joining is 0.5 e to the power minus 0.5, and probability of 0 leaving, given that nt was 1, so this will be basically e to the power minus 1, plus probability of 2 joining. This will be 1 minus 1.5 e to the power minus 0.5 into probability of 1 is leaving, given that there were, let's say, 2 of them already there. So this will be e to the power minus 1 itself. And now if you solve this, so this could be further simplified, just solving instead of putting the entire thing on calculator. Take e to the power minus 1 common. This will come out to be 1 minus e to the power minus 0.5 into e to the power minus 1, and this would be nothing but what was there, 0.144 was it? Let me just check that. Yes, so it was coming out to be 0.14475, which is matching till 5 decimal places, which we have over there. So this was the second one. Third one, NT02. Now there is just one possibility, that is 2 are joining and 0 are leaving. There is no other possibility. So this will be basically 2 of them joining is 1 minus 1.5 e to the power minus 0.5, and 0 of them leaving is e to the power minus 1. This will come out to be 0.03318. Now I was able to get NT02, NT01, and then I knew obviously NT00 had to be 1 minus this. From examination point of view, you could leave till there itself. You should have got the marks. But if you want to understand intuitive, how to get this from the scratch logically without using the fact that all of the rows add up to 1. This was the technique. Next, let's move forward to the other 3 sets, the second row. NT10. So what are the possibilities for this? NT10 means you're starting with 1 customer in the queue, 0 is there. So one possibility is there 0 joining and 1 leaving. Another possibility is 1 joining and 2 leaving. Note that 2 cannot join because there is already 1 in the queue. So at the most 1 can join. So keep this in mind. So the probability over here is 0 joining. Okay, given that it's already 1, doesn't matter because this probability remains the same, which is e to the power minus 0.5. Now, at the beginning of the day, there was 1, right? Then 0 joined. So at just before the end of the day, there was 1 in the queue. How many could maximum leave? 1 only. So this will be 1 minus e to the power minus 1. So this is basically nothing but the probability that B is equal to 1 given NT equal to 1, where your NT basically means that just before the end of the day, how many customers are waiting in the queue. If you want, instead of describing NT, you could have wrote it in words as well. Just that if you write it in words, you need to keep on repeating that. So that is why it's easier that when you represent a particular event in words through some notation. So again, let me just clarify. Technically, here NT is wrong because NT is another thing. So this should be denoted by, let's say, CJ, where CJ is the number of customers waiting in the queue just before the end of the day. And from here I will get the particular answer. Sorry, this is 0 joining and 1 leaving, then 1 joining. Given that there is already 1 over here, okay, so the probability of another one joining is 1 minus e to the power minus 0.5. This is basically probability A equal to 1 given nt is equal to 1. And then I multiply with this 2 leaving, which is 1 minus 2 e to the power minus 1. And from here I'll get the answer. Similarly, nt11, one possibility is 0 joining and 0 leaving. Another possibility is 1 joining and 1 leaving. So here the probability will come out to be e to the power minus 0.5 into e to the power minus 1 plus 1 joining is 1 minus e to the power minus 1 into 1 leaving. So there is 2 of them. So 1 leaving is e to the power minus 1. And I'll get the particular answer over there as well. Let me just check this once. NT11 was coming out to be this only 0.5. One minus e to the power minus 1. Right. So now next step which I would have is basically NT12, where the only possibility is that one customer is joining. There is no other possibility. So this would be basically probability that A takes the value 1, which given that it's 1, which is nothing but 1 minus e to the power minus 1. Now note that we have already calculated this 1 minus e to the power minus 1 if I'm not wrong, or we haven't. So if I take you back to the solution, this 0.14475, okay, this comes out to be 1 minus e to the power minus 1. So we have already got that. Now moving back to this, just a second, let me just check if I'm missing out anything. NT11 is basically 0, 0 and 1, 1. This is 0, this is 0, 1 is 1 minus e to the power minus 1.5. 0 joining and 0 leaving. If 0 have joined, so e to the power minus 1, and if 1 has joined 2, this will be again e to the power minus 1 over here. So NT11 is coming out to be 0.48, that is fine, and NT12 is 1 minus e to the power minus 1, which let me just quickly recalculate to check if doing it correctly. No, one customer is joining. So this shall be, sorry, this will be 1 minus e to the power minus 0.5. NT12, sorry, this is coming out to be wrong. We already have a one customer. We need one customer to join the queue and none to leave. So this is basically equivalent to one customer joining and 0 is leaving. Obviously, I missed that probability, and 0 is leaving. So this shall be 1 minus e to the power minus 0.5 into 0 is leaving, given that there are 2, which is nothing but e to the power minus 1. And if we'll see, this comes out to be 0.144795. Yeah. So yes, this is coming out to be. Now, the last one are the easiest test, NT20. You're starting with 2 over here, right? There are already 2 in the queue. So at the beginning of day, nobody can enter, right? So that is probability 1 only. So this is gonna be basically 0 entering, 0 joining, and 2 leaving. So this will be nothing but 1 probability of 0 joining, given that it's already empty as 2, into 2 leaving, which is basically 1 minus 2 e to the power minus 1. Similarly, nt 2 1, this is basically 0 joining and 1 leaving, which again would be 1 into e to the power minus 1, which is nothing but e to the power minus 1. And nt22 is basically 0 joining and 0 leaving, which is nothing but 1 into e to the power minus 1, which is again nothing but e to the power minus 1. So this was the whole question. I hope that all the viewers did found this video interesting. In case you liked the video, don't forget to like the video on our YouTube channel. Don't forget to subscribe to it as well, so that you are updated with all our latest content. And in case of any further queries, or in case you feel that something which we have explained here is not correct, please feel free to mention it in the comment section. We'll definitely take a look at it. And in case we find any errors, we would be commenting a particular rectification for it as well. Thank you, everyone.